in a few seconds. I'm going to, okay, it's recording. Okay, good. So in today's lecture, we're going to continue talking about Thevenin and Norton equivalent circuits, topic that we've discussed in the previous class. But before that, just a reminder about quiz 3. So quiz 3 will be inshallah on Wednesday during the class time. The material for that is going to be 4.5, which is mesh analysis, until 4.11, which is Thevenin and Norton equivalent circuit. So the same instructions the quizzes 1 and 2. So make sure to use this opportunity to actually study, kill 2 birds with 1 stone. So you study for the exam and you study for the quiz.
Yes, Doctor. Is there a possibility that quiz 3 can be postponed to Sunday?
We cannot, because if we postpone it until Sunday, then we'll have quiz on Wednesday as well. So it's either we have few quizzes, fewer than 5. From these, we can actually choose which quiz to. We have freedom on moving quizzes, or we can have as many quizzes that we have fixed dates. So
okay.
The summer is only 7.5 weeks, and we have 5 quizzes, so we cannot actually postpone. Plus, we're not going to get any quiz in the week of the midterm and the first week. So this leaves us with no options to move any quiz, actually. Okay. It's not an optimal solution, but what can we do? If we have actually extra time, if it was physical, then we can have more quizzes. But you've seen that each quiz takes up to 40 minutes of the class, which is a lot. Okay. So just go over what we've done last time. So we had a situation where we have a very complicated circuit, and we want to replace it by a simpler one. There are multiple reasons for that. One is or the main reason is you don't care about what's going on inside the circuit. You care about what the output, what this circuit is going to give you, and how it's going to affect or how it's going to behave when you connect it to another circuit that you are interested in. So this contribution is captured with something called covalent circuits. We have 2 well-known equivalent circuits. The first one is Thevenin, and the second one is Norton. So you see here, Thevenin equivalent circuit replaces a circuit with a voltage source in series with the resistance. And a Norton equivalent circuit replaces a circuit by a current source in parallel with a resistor. So the relation between the short circuit current, and the Thevenin voltage is by Ohm's law. And you can see that this one is source transport version of this one, and vice versa. So if you recall in the previous lecture, we talked about the first case where we have what we have are independent sources. Finding the voltage, the Thevenin voltage is not something different. It doesn't change when you change the configuration. But finding the Thevenin resistance is completely different if you have independent sources compared to the case where you have a dependent source. So let me just. I think it's worth spending some time on classifying problems associated with finding Thevenin and Norton equivalent circuit. So the first thing is you ask yourself. First of all, we know what to do. So we know that we need to find a Thevenin voltage or open circuit voltage and the Thevenin resistance between the terminals that we are interested in. But the methods that we're going to use, they're different. So maybe the first thing that you ask yourself is, do I have dependent sources? So if your answer is no, then you will have two options. You have then to find phi Thevenin, you need to do so first is start with phi Thevenin. Then we move to R Thevenin. Okay, so for phi Thevenin, you have 4 options to find the Thevenin voltage. So the first one is using node voltage method. The second one is using mesh current method. The third option is use source transformation. And the fourth option is KCL, KVL, and the Ohm's law. Meaning that the circuit is so simple that you don't need to apply source transformation or node voltage method or mesh current method. So again here, this is OR. So you have 4 options. Now what happens if we're talking about the Thevenin resistance here. And in this case, you have actually 2 options. So what are these 2 options? So the first one is deactivate all independent sources, which is usually the easiest one. The second option is you find I short circuit and use, since you found phi Thevenin previously, and use R Thevenin equals to phi Thevenin divided by I short circuit. So now, what happens if you have a dependent source? So we explored this option, having an independent where we don't have independent source. So let's explore what's going on when we have a dependent source. So finding the Thevenin voltage will not be different. So again, I'm gonna write it here. So for Thevenin voltage, we're gonna use exactly the same techniques as in the previous case. And to avoid writing everything. Can copy it. So finding the Thevenin voltage does not depend on whether we have a dependent source or independent source, because you can still use the same method. But now, what about the Thevenin resistance here? So this is a very interesting situation. So you have so this will be our first case. This will be our second case. So the first case will be using we'll be finding I short circuit, something similar to what we had when we talked about the case where we don't have a dependent source. So find I short circuit, then R Thevenin equals to V Thevenin divided by I short circuit. So this is the first option. The second option is something that we're going to explore today. It's we deactivate all independent sources. Then we apply a test source. Then R Thevenin will be the test source voltage divided by the test source current. So you either apply test voltage source with specific voltage that you know in advance and find the current in terms of the voltage, and the ratios will give you the resistance, or you do the other way around. You apply a test current and you find the voltage based on the voltage response to that test source, and taking the ratio will give you the Thevenin resistance. So we see that we have two different situations. If we have independent sources, all what you have is independent sources, things are much simpler. If we have a dependent source, then finding the voltage will not be different. The only difference here is finding the Thevenin resistance. So we have two options: either to find the short circuit current and take the ratio of the Thevenin voltage, and the other thing is deactivate all sources and finding the ratio. This tells you one important thing, that usually it's better to start with finding the Thevenin voltage than Thevenin resistance. Okay, let's have an exercise. And Ibrahim, this question.
Yes, doctor. For the I short circuit, it's the same for both cases.
Yes.
Okay.
But sometimes is finding one. Sometimes one method is easier than the other. So you need to spend a few seconds, or like half a minute, trying to explore, thinking about which option is better for yourself. Okay. In this exercise, we are asked to find the Thevenin equivalent circuit with respect to the terminals A and B. So usually what you have is something like this. Say like this one is 10 ohm. And I'm asking you to find the Thevenin resistance seen by the 10 ohm, the Thevenin equivalent circuit seen by the 10 ohm resistance. So the first thing is you delete this one, then you start your calculation. Anyhow, in this situation, so we need to find the Thevenin voltage. So let's start. And to give myself enough space, I need to go here. Okay. So there are multiple ways of solving this one. You can apply a node voltage method. You can apply a mesh current method. And frankly speaking, maybe the mesh current method will be easier. Well, it's not. They're going to be exactly the same. So for the mesh current method, you have two equations. For the node voltage method, you also have two equations. The only difference here is the node voltage method. The Thevenin voltage is actually one of the node voltages. Ibrahim, question?
No, I was gonna participate.
Okay, hold on a second. So the Thevenin voltage is actually one of the node voltages, so I don't need to apply Ohm's law. Plus the Thevenin and not the node voltage method and the mesh current method, they're both going to give me exactly the same number of equations. So I have the freedom to choose which method to use. Ibrahim, let's apply the Thevenin. Let's apply the node voltage method.
For V1, we have V1 minus 280 over 2 kilo ohm.
Okay.
Plus V1 over 2 kilo ohm. V1 minus V Thevenin over 2 kilo ohm. Plus 0.2 I delta, which is
We'll come to it. I guess it's not straightforward in this case. Okay, very good. Let's simplify this one. 3 divided by 2k, 1 over 2k, Thevenin plus 0.2 I delta equals to 280 divided by 2k. This is the first equation. Second equation, let's see. Ahmed Al-Hamad.
For V thickener is V thickener minus V1 over 2.
Okay, I was ahead of you, so V Thevenin minus V1
over 2.
2k.
And minus 0.2 I delta.
I delta equals to 0, so if I simplify it, so, by the way, participation is counted whether you say it correctly or incorrectly. So it doesn't matter that you have the right answer, because I'm not checking the right answer. This is for the exams, but for participation, it's not necessarily that you get it right. Okay. Yasser.
Yes, we need to add a third equation, which is I delta. It will be 280 minus V1 over 2K.
Exactly, 280 minus V1 divided by 2K. So 1 over 2K V1 plus I delta equals to 280 divided by 2K. This is the third equation. So if I solve for them, I'll get V1 equals to 120 volts. The Thevenin And this is the beauty of using node voltage method, is that the node voltage is one of the node voltages is actually the Thevenin voltage. Okay. Now the next step is actually to find the Thevenin resistance. So in this case, I'm going to use, you can use either test source or short circuit. I'm going to use a short circuit approach because I want to apply mesh current method. So I will go ahead and take this one and connect a short circuit here and apply a mesh current method. The advantage of using the mesh current method is that if this one is IA, IB, and yes, that's exactly it. So this one is known, and IC is actually the short circuit. Oh, before that, there is one simplification here. What do you think, Shabab? Ziad?
I don't know, we make a super mesh.
Not really. Remember here we have a short circuit in parallel with 5.6 kilo ohm. So what's the equivalent resistance here?
Again, so
We have a short circuit in parallel with 5.6 ohm. What's the equivalent resistance?
0.
Okay, so it will be short circuit. So the number of equations here is significantly reduced. So this one will be IA. This is I short circuit. And they know this one. This one is 0.2 I delta. And I delta is actually IA now in this case.
Doctor, I think we have missed a resistor at 2 kilo ohm.
Okay. Thank you. Takrim?
Yes, doctor. Now we need to choose a mesh and apply a KVL on it.
Yes, so let's start with IA.
So I minus 240 volt plus 2K multiplied with IA plus 2K multiplied with IA minus IP. Or IS.
So I know that IB is I short circuit. So I'm just gonna write it this way. So 4K IA minus 2K I short circuit equals to 280. This is the first equation. The second equation is Ahmed Nafeh.
2 IC.
Okay, 2K I short circuit.
I short circuit plus minus the I which is above that, which is
So
0.2 I delta.
So let's start from here. So minus 2K I short circuit minus IA. Then 2K I short circuit minus
Minus 0.2 IA.
I delta. I delta is I delta is IA. equals to 0.
Yeah.
So this is going to give me minus 2.4 KIA plus 4K I short circuit equals to 0. So if I solve for it, I will get. So now I have the short circuit current, I have the open circuit voltage. So the Thevenin equivalent resistance is following. So if I draw the Thevenin equivalent circuit, it's going to be something like this. Okay, very good. So now let's. So the third case is just the case that I explained, where we have a dependent source, but we want to find R Thevenin using a test source. So just to elaborate more on this case, so if we connect, first of all, we need to deactivate all independent sources. So if we have an independent source, we deactivate it, but if we have a dependent source, we keep it. Then we need to connect test voltage or test current. So if you connect a test voltage, then you need to express the current between the terminals in terms of the test voltage as a function of the test voltage. If you connect a current source, however, you need to express the voltage between the terminals in terms of the current source. Then you will have one of them is a function of the other. So if you take the ratio, this will gonna give you the Thevenin equivalent resistance. So let's illustrate this with an example. So here we are asked to find the Thevenin equivalent circuit with respect to the terminals A and B. So again, the very first step is to find the Thevenin voltage. And if we want to find the Thevenin voltage, maybe here it's easier to apply the node voltage method for an obvious reason here, that you only have one, or even if you, it's like the, if you, let me make sure. Okay. So if we apply the node voltage, then we have this one, V1, which we know is 24 volts. We have this one is 3 Thevenin. And we know that Ix is simply V Thevenin divided by 8. So let's apply the node voltage method here and see what happens. Adi. Okay. So let us.
We'll start with one node. With one.
Node 1?
Yes.
We know the.
Oh, we already know it. Right. V Thevenin.
So we have only one node voltage.
Yeah. V Thevenin minus V1 over V over 2 plus 3i.
Okay. 3ix. Okay.
plus 4i, just 4.
So if we simplify it, we will get this one. So we know that, like I said, Ix is Thevenin divided by 8. So then simplify the equation to be all in terms of Thevenin. So the resultant Thevenin voltage is 8 volts. Okay, now the question is how to find the Thevenin equivalent resistance. So let's apply the test source method. Test source. So you have the options to choose which test source to use. And in my case, I'm going to choose a test source, a test voltage source. So let's see what kind of circuit that I'm going to. So here I need to deactivate the voltage source. It's going to be short circuit. I need to deactivate the current source. It's going to be an open circuit. So I'm going to keep the 3ix, which is a dependent source, because we need to keep the dependent source. Remember, this is the location of the voltage source, and this is the location of the independent current source. And then this is the test voltage source. And they need to find the test current here, IT. So what do you think, Shabab, the best approach to do that? So let's see, Hassan Sayer.
Doctor, wouldn't it be best to choose a short circuit method if you have dependent and independent?
It doesn't matter. It doesn't matter. You see here that this method is easier actually. Okay. Any suggestions, Shabab?
We will use node voltage method.
Why? Okay, there is an easier way actually. Ibrahim.
Maybe we combine the 8 and the 2, then
We can do something like this.
Flow, or no.
Okay, so let's apply KCL here. So if I call this one, okay, let me use different curve here. I1, I2, this one, I3. So I know that by KCL, I2 is I3 plus 3ix. And what is Ix in this case is I1. Okay, so I2 will be I3 plus the I1. Now from Ohm's law, what is I1? Thevenin divided by 8, صح?
V test.
V test, sorry. V test divided by 8. because the voltage across the 8 ohm resistor is the same as the test voltage source. Okay, so what is I3 here? What do you think, Shara? What is I3? Any suggestion?
VT over 2, I guess.
Yes, VT over 2. So, because the 2 ohm is actually in parallel with the 8 ohm resistor. And they are both in parallel with the test source. Okay, now can I write everything in terms of, can I write IT in terms of VT? The answer is yes. Because IT here, so let me bring it here. IT will be I1 plus I2. We know that I1 is VT divided by 8. I2 is going to be I3 plus 3IX, which is I3 plus 3I1. We know that I1 is what? Is VT divided by 8. I3 is VT divided by 2. So IT will be equals to VT. So R Thevenin will be VT divided by IT, which is 1 ohm. So the Thevenin equivalent resistance is 8 volt, 1 ohm resistor. Okay, is it clear for that?
Yes.
Okay, very good. So now we have 3 minutes. I think we can do this very quick. So just to point out, following. Okay. So the direction of the current is actually this way. I delta is flowing this way, not the other way around. So the first thing is you ask yourself what will be the Thevenin voltage between A and B. And Suwailem, what do you think?
We use the node voltage method.
Well, here's the thing, Mohammed. What is it exactly we're missing? What's so special about this circuit?
It's not a node, the V3B.
No, we don't have an independent source. So if you keep the circuit as it is, and you try to measure the voltage or the current at any part of the circuit, you'll get 0. Because if you have an independent source, you have to have, if you have a dependent source, you have to have an independent source as well. So the independent source will generate power. The dependent source will use that power and some sort of like magnify it or adjust it somehow. So since we have no independent source, V Thevenin will be 0 volt. Prime question?
No, I was going to participate.
Okay, good. So now the next thing is to find R-Thevenin. And to find R-Thevenin here, let's apply test voltage or test current source. So maybe in this case, it will be easier to apply a test current source. You can try with a test voltage source, and you should get the same solution. But if you apply with the test source, then you probably need to use mesh analysis. Because remember, you are interested in the current itself. Okay, I will post the solution for this problem. But just to emphasize here that we are trying to apply a test source, and I want you to review this problem, review my solution, and if you have any question, please ask me, because these concepts are very important, and we've already solved eight problems on those. Yes, yes.
Doctor, I did not get why V Thevenin is equal to 0 whenever we don't have, if we don't have any independent sources in the circuit, so we don't have any voltage.
Yes. It's like you don't have a battery in your circuit and you're trying to measure that. Yes, you have an independent source here. I have a dependent source here, but this dependent source will not generate current or voltage by itself. It needs some power to be modified or like excited.
Yes, I get it. I have another question in the previous question.
Sure.
Yes.
Which one?
If I want to find V Thevenin using mesh current method.
Yes.
Yeah, I will erase the 8 ohm resistor, and then I don't know how we will draw the circuit after we erase the 8 ohm resistor.
Why?
With the short.
Okay, why do you need to erase the
Oh,
to find the Thevenin voltage?
Yeah. We should not erase it, yeah?
No, you cannot. Because you're trying to find the voltage across the 8 ohm resistor. This is a Thevenin.
So we will have 4 equations?
No, actually, you will have a super mesh here.
Yeah, super mesh.
And you will have this one is known to you. So you might try to find it as an exercise. Try to find it using mesh analysis. You should get what was the Thevenin voltage here? 8 volt. You should get Ix to be 1 ampere.
Okay, thank you.
عمر؟
ايوه دكتور، الهوم ورك الثاني بيكون على اي ماتيريال؟
I don't remember exactly. I think it's going to be on chapter 4, maybe. I don't know. I mean, okay, hold on a second. Let me double check. It's going to be on chapter 4.
Okay, thank you.
Ahmed al-Nafi.
Doctor, how many extra quizzes will we take?
Not going to take anything extra. No extra quizzes. Okay, another question?
The time for taking the picture, it's 3 minutes from what to what?
From the time I say, okay, stop writing.
Oh, okay. So it's not a specific time from when we said stop.
Yeah, from the time, because I keep record of the time when I say stop writing.
Okay.
But from that time, it's what I calculate. Leila?
Doctor, are there going to be revision sessions before the midterm?